All right, today we're jumping right into one of the most important ideas in object-oriented programming, how you can and should take complete control over your data. You know, when you really get down to it, object-oriented design gives you a fundamental choice. You can go with the simple, public property approach, where pretty much any part of your code can wander in and mess with your data. Or you can get a little more sophisticated, a little more dressed up, and take charge of exactly who gets to see your data and how they're allowed to change it. Look, leaving all your data public is definitely easy, but it's also kind of like the Wild West of programming. It means any function from anywhere in your codebase can just randomly change a value. And that leads to bugs that are an absolute nightmare to track down. It's really like leaving your front door unlocked. So how do we bring some law and order to all this chaos? Well, the answer is this incredibly powerful concept called encapsulation. It's this elegant solution where we bundle our data and the functions that work on that data together all into one neat protected package.
So let's really dig into this art of encapsulation. The best way to think about it is like you're building a fortress around your data, or maybe putting it inside a protective wrapper. The point is, you're no longer leaving it totally exposed to the outside world.
And this diagram just shows it perfectly. See, inside this capsule, our class, the variables are private. They're completely hidden from the outside. The only way in or out is through these public methods, which act like official controlled gateways.
So why bother with all this? Well, it's because it logically binds your data and functions together. It keeps that data safe from weird outside interference, and it protects against that random, uncontrolled access we were talking about. This whole thing leads right to a super important principle called data hiding. You're protecting the internal state of your object. Okay, so if our data is all hidden away inside this fortress, how do we actually, use it? That's where the official gatekeepers come in. Special functions we usually call getters and setters. And the difference between them is really simple, but it's incredibly powerful. Getters, which are sometimes called accessors, are just for reading data. They let you peek at the value of a private variable without changing a thing. Setters, on the other hand, or mutators, they're for writing data. They're the only way you should allow a private variable to be modified.
Let's think about a bank account for a second. Your PIN number? You definitely want that to be a private variable, right? So you might make a public getPin function so that you can read your own PIN. But you would almost certainly not create a public function that lets just anybody change it. This getter gives you that controlled read-only access.
Now that word indirectly is the absolute key here. You aren't just handing other parts of your code a key to the data vault. Nope, you're giving them a request form. They have to ask the getter or the setter to perform an action, and the object itself stays in complete control.
And this is where setters become so cool. They aren't just dumb gates that let any old value through. Inside a setter, you can write logic. You can perform data validation to make sure the new value actually makes sense. So, for example, you can check that a course name isn't ridiculously long before you ever allow the change to happen. Okay, so we've got this awesome, secure blueprint for our object. But how do we actually, build one? Well, for that, we need an automated construction crew called a constructor.
Seriously, think of a constructor just like this crane. Its one and only job is to build a new object, and this is crucial to initialize its starting state, making sure it's good to go the very second it's created.
So, simply put, a constructor is this special kind of function inside your class. You never call it by name. It just runs automatically one time at the exact moment a new object of that class is born. Its whole purpose in life is initialization.
Now, there are a few little rules that make constructors unique. They have to have the exact same name as the class itself. They don't return any value, not even void. And like we said, they're called automatically. Oh, and here's a neat trick. If you forget to write one, the compiler actually creates a basic empty one for you, just so your code doesn't break.
And I love this cartoon because it perfectly captures the idea of a parameterized constructor. See, instead of just creating a generic empty object, you can pass in specific values right at the moment of creation. It's like saying, hey, constructor, build me a rectangle and make sure you use 5 for the height and 6 for the width right from the very start.
And this is what that actually looks like in code. Over on the left, the employee class has a constructor that takes a name. Then on the right, in our main program, we create 2 new employees, Ali and Shuja, and we pass their names directly into the creation process.
So these objects are born already knowing their names. It's pretty efficient.
So we've built a really solid foundation here, but now it's time to level up, to add a layer of professional nuance. It's time to think beyond just automatically slapping getters and setters on everything and start creating a real master plan for our data.
Which, of course, brings us to a really critical design question. If you have, say, 10 private variables in your class, should you just mindlessly write 20 functions, a getter and a setter for every single one?
Well, what if I told you that you don't have to? In fact, blindly adding getters and setters for every single variable can actually defeat the whole purpose of encapsulation we're trying to achieve. It's just a tiny step away from making everything public again.
Here's the bottom line. Encapsulation isn't about making it impossible to change an object state. It's about having a thoughtful, reasonable policy for how and when that state is allowed to be changed.
So what does a smart policy actually look like? Well, some data is purely for the object's internal use. It needs no getters or setters at all. Some data should be read only, like that bank pin we talked about. So it gets a getter, but absolutely no setter. And if you have two variables that always have to be consistent with each other, you create one method to change them both together, and instead of a generic set balance, you create methods with more meaning, like credit or debit.
So let's put it all together. We've seen how constructors build our objects and how a smart access policy controls them during their life. This gives us a glimpse of the whole picture, the object's entire life cycle. Just like constructors are called automatically when an object is created, a special function called a destructor is called when it's no longer needed. And what's fascinating is the order. See how when func ends, the objects created inside it are destroyed in the reverse order of their creation? It's this automatic, predictable cleanup that's the final piece of the puzzle. It makes sure our data is managed cleanly from birth all the way to destruction.
And there you have it. From the automatic birth of an object with a constructor to the controlled, thoughtful access during its life, all the way to its orderly cleanup. You are now in command. You control the what, the how, and the when of your data's entire life cycle. So the only question left is, what are you going to build with that power?